Hi everyone, my name is Anisha, and today I'll show one implementation of creating a computerized adaptive test using binary search trees. Computerized adaptive tests are a type of assessment method that dynamically adjusts the difficulty level of test questions based on whether a user has answered the previous question correctly or not. So you usually start with a medium or medium easy question. If the question was answered correctly or incorrectly, the system would recalculate the test taker's ability estimate and keep providing them with new questions with readjusted difficulty levels based on the correctness of the previous questions. Once the termination criteria is met, the test software can determine the test taker's skills and proficiency. This is usually much more efficient than traditional test taking methods because you can very quickly determine the level and proficiency of a user using much fewer questions. So let's look at an example using a binary search tree. Suppose we have a binary search tree consisting of questions with varying levels of difficulty from 0 to 15. The quiz starts at a medium easy difficulty root node. Correct answers would lead to harder questions, and that's the right children, and incorrect answers would lead to easier ones, that's the left children. The termination criteria for this binary search tree is when we reach a leaf node and there's no further questions, the quiz ends. If you answer a question incorrectly, you'll be given an easier question with a difficulty level of 3. So the left child of 5 is 3, which is why we now give a question with difficulty level of 3. But if you answer the question ranked difficulty level 4, rank level 3 correctly, you're given a tougher question, which is of level 4. Since this is a leaf node, the quiz ends. A correct answer would indicate that the user can handle questions up to difficulty level 4, while an incorrect answer would cap their ability at level 3. Now, here is the code structure for this implementation. I've got a code question node class, which takes in, which has the following variables. It has a string that's just a question, an answer to the question, a difficulty level, a left node, and a right node. The quiz iterator class would facilitate navigating through the binary search tree. It would just adapt the quiz based on the user's answers by moving to a more difficult question for correct answers and an easier one for the incorrect answers. The adaptive quiz class manages the binary search tree by inserting questions based on difficulty and providing methods to retrieve the root node. And finally, the main class would just initialize the quiz using lots of quiz questions and also provide the user an interface to interact with the quiz. Let us now implement the adaptive quiz class, which is just a binary search tree that we're trying to implement. So we've got a variable called root of type question node. This is the root node of the binary search tree. It starts as a null when the adaptive quiz object is initialized. We'll also create our constructor, which is the adaptive quiz constructor, and initialize our root question node to null. Next, we'll create the method insert. The insert method is used to add a new question to the binary search tree, and it'll also call a recursive function to find the correct position for each node in the tree based on the difficulty level, which is an integer. So we've got the insert method, takes in a question, type string, takes in an answer of type string again, and takes in an integer, a difficulty level of type integer. So now we'll just add a value to root, and this is the recursive function that I was talking about. Just add in some parameter, some arguments to this. and then create our recursive function. So our recursive function would return a question node, and we'll call it insert recursive. It takes in a question node as an input. So the current question node would be input. It takes in a question, an answer, and a difficulty level. And so if the current node is null, then we would just place it in, it'll just create a new question node and place it into the tree. So we've again got our question, answer, and difficulty. Now if the value is not null and the difficulty is less than the difficulty of the current node, then it is placed in the left subtree. So we've got insert recursive current. This is the, so this just, oops. So this just keeps happening as long as our binary search tree is correctly made. Otherwise, if the difficulty level is greater than or equal to the current difficulty level, this is also to account for the fact that we may have questions with similar difficulty levels. Then we just insert it to the right node. So current dot right. Let's add the question, answer, difficulty level. Oh, I think, yep, this was missing. And finally, we'll return the updated subtree with the new node in place. Just call it that. And that's our implementation of our binary search tree. But we also have a method called getRoot. What this function does is it'll return a root of the binary search tree, which will allow access to the entire tree structure from outside the class. That's it for this tutorial. I hope you learned how to create a binary search tree. Thank you.